Hi. In this section of our podcasting course, we're going to look at some of the theory behind audio recording. So we'll briefly look at microphones and how they work, and we'll explore sound levels and look at the effect compression can have when applied to audio. Finally, I lay out some recording tips for both in-person and remote online recordings. This is theory or a short background of recording. There'll also be a practical tutorial on recording directly into Audacity and also with a phone elsewhere on this course. So microphones are devices that convert energy from one form to another, acoustic energy to electrical energy. Speakers do the opposite of this. They convert electrical energy back to acoustic energy. Microphones have a number of characteristics. So the transient response is how quickly the mic responds to changes in sound. The frequency response is the range of pitches that it can react to, very, very low sounds to very, very high sounds. The sensitivity and dynamic response of a mic refers to the variance it detects between a very low volume and very high volume sounds. And there's other characteristics around microphones such as size, weight, form factor, etc., etc. Reliability would also be a factor too. Microphones also have what's called a directional property. This is the area around the microphone head that picks up sound. Some are built to focus on sound directly in front of the mic head. That's a cardioid pattern. Others are omnidirectional, which means they pick up sound from 360 degrees. Generally speaking, for podcasts, you're better off with a directional mic of some kind, which can be focused on an individual's voice. Some people use 360 mics for round table discussions, but the problem with that is that it's going to pick up every person equally. So if you have somebody talking and you have somebody else over there, breathing heavily, it's going to pick up both at the same time. So, it's better off having individual mics if possible. There's another kind of microphone characteristic of microphones. That's the difference between dynamic and condenser mics. I'm not really going to get into it in too much detail. Dynamic mics are simpler. Condenser mics allow for greater frequency response and a warmer sound, but they are more complicated to set up. They often need a thing called phantom power. Condenser mics would be used a lot for recording music when you're trying to get the sweetest sound possible. Which is better? Well, it kind of depends, really. There's no one right answer. The best mic is the mic that you have and is best suited to you. Obviously, the more expensive mics give you better sound quality than cheaper mics. For podcasting, I'd be chiefly concerned with things like directional pattern. Cardioid mics provide a nice sound area. They pick up the sound directly in front of the mic and don't focus too much on what's behind the mic. A figure of 8 mic can be pretty good because that picks up the sound from directly in front of the mic and directly behind the mic. So if you're having a conversation between two people, that can be very, very good because you get the mic between you and you get one on one side, one on the other. Most USB podcasting mics use cardioid patterns. That's the likes of the Rode NT USB, the Blue Yeti, although a lot of them you can actually change the direction. The pattern on the microphone as well. It might be a setting that you can change. If you have a musician in your life, there's a good chance they have a Shure SM58 somewhere. These are the kind of the workhorse microphones of the music industry. They're brilliant mics. They're incredibly reliable, and you can get really good results. Those use an XLR connection, which can't be directly plugged into a computer though, so you would need an audio card. So a USB mic might be better off. Equally, you could use the mic from your laptop or a mic from your smartphone as well, but a dedicated mic will be better. Sound levels are the volume at which you're recording. Usually when you're recording with a microphone, there might be a gain knob that you can kind of adjust. Or it might be present on an audio interface like a mixing desk. Or sometimes if it's just a USB mic, there might be a software control that you can use on your computer. The input level is different to the output level. It's basically setting how sensitive you want the mic to be when recording. Normally there'll be a meter of some kind that displays the recording volume as you speak into the microphone. Now, sound is measured in decibels. Usually 0 is the maximum point, and everything else is a negative number from there. -10, -20, -5, etc. Sound is additive, which means that two sounds at the same volume will have double the overall volume than one sound on its own. Two voices speaking at the same time will be twice as loud as one voice. Now, decibels are measured, it's a logarithmic scale, which means 5 dB isn't twice as loud as -10 dB. So I'm not going to give you exact values to aim for without getting into, sound engineering nerddom. If you're recording, I would say try to record at recording voices, right? Try to record at -20 dB. That means you have enough headroom if somebody makes a sharp sound, like maybe they laugh, if there's a sudden jump in volume. And you can always make it louder later in the editing process, which we'll talk about later on. What you don't want to do is record at too loud a volume. That's where everything is above 0 dB. That gives us what's called peaking or distortion. The sound will be harsh and very unpleasant, and it'll actually sound really bad in your ears. So -20, it's a good level to aim for. It gives you plenty of headroom, and we can mix multiple voices together without peaking, hopefully. Also, if you have one voice that's too low in the mix and you've recorded everyone separately, you can boost that one voice so that all the voices are at an equilibrium. And if on the individual sound peaks, you cannot undistort it later. If something peaks, it's peaked and that's it. Also, the best equipment that you have are these two ears on the side of your head. Listen to the sound as you're recording it. Is it too loud? Is it too quiet? How do the two sounds compare against each other? If you've got like two voices, is one voice significantly louder than the other? If that is the case, you might need to adjust the recording level. So there you go. Now, compression. Dynamic compression is an audio effect. It's not to be confused with file compression. File compression is where you try to squish large volumes of data into a smaller space. So that would be things like a zip file or in the case of sound, MP3. Dynamic compression though is an audio effect. What it does is it helps to level out the sound. Basically, you can make the quiet bits louder and the louder bits more quiet. The idea is that it'll kind of squish the sound within a certain threshold. Here is an example of good use of compression.
This recording of my voice has been given a small amount of dynamic compression in order to give the voice extra bite and maintain maximum audibility.
That sounds quite nice, and compression can help to smooth out the sound. The settings on a compression plugin can appear confusing if you're not used to it. There's values like threshold rate, attack, release. They refer to how fast the compression is applied and to what extent it reshapes the sound. It's not a magic bullet, but it can help you smooth out those sounds. When mixing sound sources together, you're much better off trying to achieve an equilibrium between sounds by manipulating the volumes manually. In my experience, compression is a really good thing to apply to a podcast after you've manually mixed it together and you want to smooth out rough edges. Also, if you apply too much compression, it can ruin the audio, as you'll hear in this example.
This recording of my voice has been given excessive dynamic compression. Although the level is maintained as high as possible, any background noise is increased during the pauses, causing a pumping effect.
So if you're new to sound, I would recommend using one of the preset values on a compressor if you're using a compressor at all. Whichever package you're using, Audacity, or if you're using something else like Adobe Audition or GarageBand or whatever, there will be presets there that you can use. Okay, so here's some random tips that I'll give you for recording. So the first one is to record at low volumes. If you record at low enough a volume, peaking is unlikely. You can always make the sound louder later on. And as I said, -20 dB is a good target. Each microphone has its own characteristics. Everyone is different. As you use a mic, you'll get to know the way it picks up sound and where those sweet spots are. The more practice you have, the better sound you'll get. Watch out for microphone placement. Where you place a mic is important. If the mic is too close to somebody's mouth, the sound might be too harsh or too loud. It depends again how sensitive the mic is. It might also pick up a lot of breath noise, or there's other things. I find putting a mic at the nose or under the chin is a really good place, because this also helps to reduce two types of unwanted sound: plosives and sibilants. Now, plosives are sudden bursts of air that hit the mic, and they're often caused by words beginning with the letter P or B. It can sound like a bit of an explosion on the mic. A boom. Sibilance comes from S and T sounds. If those are overly pronounced, if the mic is too close to the mouth, it can make somebody sound like they have a pronounced lisp when they actually might not. So having the mic at the nose or under the chin helps to reduce those bursts of air hitting the head of the microphone. Use headphones when recording so that you can hear what things sound like. If you wear headphones, you might notice unwanted sounds, things like a clock ticking or somebody banging their hands on the table. And then you'll be able to adjust the mic or the gain levels if there's any of those things happening. Check, double check, triple check everything is working before you start recording. Sod's Law says that something will go horribly wrong at the worst possible time. Try to reduce those opportunities as best you can. Check your levels before you start to record. The old rule about garbage in and garbage out applies. Background noise. It can be tough when you're recording. Sometimes background noise can actually be nice. It can give you a nice atmosphere. It can give you a sense of space. For example, if you recorded an interview with somebody in a cafe, it can give a bit of a bustle. It can make it sound like something is happening and you're eavesdropping on somebody's conversation, provided the background noise isn't too loud and you can hear the voices properly. There's other background noise that can be off-putting. Things like air conditioners or clocks ticking, smoke alarms that beep intermittently. Those are the kind of things that are really annoying. If you find that you're recording somewhere where those noises are happening, try and move to a different spot. Trust your ears. They are the best bit of sound equipment that you have. If it sounds bad to you, it's probably bad. If it sounds good to you, it might be okay. Mobile phones. In terms of background noise, mobile phones are one of the worst culprits. If you can, you don't have, I'm not going to say to you, everyone has to turn off their phones. It's just not going to happen. But what you can do is make sure people put their phones on mute. The last thing you want is a really good conversation being interrupted by a phone pinging away, whether it's a million WhatsApp messages or somebody's embarrassing ringtone. Watch, if you're using a handheld mic, watch for your fingers, that they're not covering the actual mic head itself, particularly if somebody's a novice. Or the other thing that might happen is you could be holding the mic and you might have a little twitch where you're kind of tapping your thumb on the mic. That will sound like a boom, 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 a tap, 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 tap on the mic. So you're going to watch for that. So check for handling noises when you're recording with a microphone. Make notes and any edit points as you go, if you can. So I've said to you before about having a pen and paper, maybe your questions. If there's an edit point that you need to make, maybe somebody says something incorrectly and they want to restart, just make a little note of it, where it is, and jot it down on a piece of paper. It can make your editing much easier later on. Another one that I like to do is, if there's going to be an edit point, I will also often do a clap. I'm not going to do it here now because it'll sound really loud because I have a microphone in front of me. Do a clap, and that will show up as a line on the waveform when I'm editing it later on. So I know that there's an edit point there. Things like that. Batteries. If you're using something that isn't plugged into the mains, make sure the batteries are charged. If it has removable batteries, if it's like a handheld recorder, bring spare batteries. Again, Sod's Law says if you have them, you won't need them. But if you don't have them, you will need them. And finally, Trust your ears. I know I said that already. I'm saying it again for good measure. Trust your ears. Here are a few tips for recording remotely. That means if you're recording over the internet. If it's possible, try to record locally at all ends. That means let's say you're recording an interview between two people. You record yourself locally, say into Audacity or whatever it might be, and the other person might do the same. If you can do that, it means you're going to get nice clean audio at either sides. Then the person can send you their audio and you can mix them together. I'm also aware that that's not always possible. There are systems that you can use to help with this. There's a good system that I've used for years called Zencastr. Another one a lot of people use called Riverside FM. How those work is beyond the scope of this course. But Zoom is quite good for recording remotely. It can work. It is possible to record over Zoom. There's one of the settings in Zoom, and I'll show this in one of the tutorials, where you can have it set so that there's a separate audio track for each participant. What that means is that if you've got 3 people on the call, you'll get 3 separate audio tracks, one for Tom, one for Dick, and one for Harry. And it makes that much better that you can try to then balance the voices in the editing process rather than necessarily having to worry about it when you're recording. So yeah, Zoom, it works, and obviously the quality of Zoom has gone up significantly over the last number. If you are editing a multi-track audio project, particularly one that's been recorded over Zoom, it will take time, so be prepared that it might take you as long to edit as it did to record. It might even take you longer if there's problematic audio, so just watch out for that. So to summarize this section, the microphone is the primary piece of equipment in your tool belt. Microphones, there's a whole load of characteristics associated with them. Audio compression can be your friend, it can also be your foe, and the more recordings you make, the better you'll get at it. There's a few references, a few more, and we'll pick up with editing next.